So you want to know more about Sugar Bay 2011 embedded desktop platform and its benefits? Well, you've come to the right place. My name is Mike Munson. I'm responsible for the 2011 scalable embedded product line, using the second generation Intel Core microarchitecture, formerly named Sandy Bridge. Along with me is Amit Aneja. Amit is responsible for the embedded desktop and workstation product line. Well, the goal of this video is to highlight three major new advancements in the 2011 embedded desktop platform and how those enhancements can translate into customer benefits. We have brought in a 2011 embedded desktop running Sandy Bridge. This is to showcase the features and benefits we're talking about today. This demo is based on a digital signage system with anonymous video analytics running on the embedded desktop platform. As we talk about each feature, we'll show real-world working examples. And now, Amit will give you the background on the platform.
Thanks, Mike. Sugar Bay is the 2011 embedded desktop class 2-chip platform with second-generation Intel Core processor, formerly codenamed Sandy Bridge, and Intel 6 series chipset, formerly codenamed Cougar Point. The three new advancements in the platform are a new, enhanced microarchitecture with full integration of processor and graphics in a monolithic die, new graphics and media capabilities, and the newest addition to Intel's instruction set architecture, AVX, or Advanced Vector Extension. Now let me explain in a bit more detail what these three are, and then Mike will explain how these next-generation features can enable best-in-class Intel architecture-based embedded products. In the second-generation Intel Core or Sandy Bridge processor family, we have a completely new processor microarchitecture built with Intel's 32nm process technology. There are several new microarchitecture innovations like the addition of decoded micro-op cache. Decoded micro-op cache basically means the broken down units of micro instructions known as micro-ops that execute on the processor execution engines. Now they are already decoded and cached. So for software code that has a lot of loops or repetitive code execution, this may really boost the performance. Another innovation is 2 load and store ports compared to 1 load and 1 store in the previous architecture, to keep up the bandwidth of data load and store to match faster instruction execution, like for example with floating point operations using Intel AVX. Grounds-up rebuild of out-of-order execution block and the execution units, among many other enhancements that allow the new core design to execute more instructions per clock. The uncore design now has a high bandwidth and low latency ring interconnect, as well as integrated memory controller, which increases bandwidth and reduces latencies for internal data transfers. This leads to significant performance improvements. In addition, there are technologies like next-generation Intel Turbo Boost Technology 2.0 to opportunistically enhance computing or graphics performance, enabling a richer user experience. Now Mike will talk more about the benefits of these microarchitecture innovations.
Thanks, Amit. So this sounds good, but how can our customers benefit from this new design? With the new performance improvements over previous generations, customers can continue to offer leading-edge products in their product portfolio. This, along with platform scalability, will allow our customers to offer a full portfolio stack from value all the way up to high-end. With the brand new Intel Turbo Boost Technology 2.0, the new microarchitecture, and the new monolithic die, customers can design systems that can service even the most compute-intensive applications, while staying within the specified thermal envelope.
Let's talk about the graphics architecture now. Sandy Bridge processor graphics are now integrated into the same die as the general purpose processor cores and are built on Intel's latest and greatest 32nm process technology. As a result, the overall processor has a very efficient hardware-controlled power budget sharing mechanism. The high bandwidth last level cache is now shared between processor and graphics cores, enabling low latency and high bandwidth data access for graphics workloads, with reduced system memory accesses improving the overall graphics performance. The processor graphics engine at a high level contains an array of parallel next-generation execution units, or EUs, for 3D graphics. Several new instructions have been added, including support for new transcendental math operations. This makes the EUs capable of providing twice the throughput per execution unit compared to previous generation. The media capabilities on Sandy Bridge are further improved, with hardware acceleration for video decode and encode, and advanced video processing logic like denoise, deinterlace, sharpen, scaling, color processing, etc. So how do these graphics architecture enhancements lead to a stunning visual experience for the end user? I will let Mike explain that.
So the brand new 3D graphics technology built into the platform offers the same rich graphics experience as some entry-level discrete cards. This allows you to offer a visually stunning user experience with immersive 3D, but not have the additional cost or thermals of a discrete graphics card. Intel QuickSync HD Video is the technology name for the hardware acceleration. This is for customers whose end users are interested in stutter-free HD streaming video in or out. Segments such as digital security and surveillance have been able to stream several HD video cameras all at once. Segments such as digital signage can benefit from having lifelike HD content playing out through their display. The results we have seen using this new technology are fantastic. If you look closely at this demo, you can see how it is capturing, processing, and displaying the camera's image on the panel, as well as streaming out media content for consumer consumption. This is all done with the 2011 embedded desktop platform, with no additional discrete graphics or video analytics coprocessors.
Thanks, Mike. The third advancement I want to highlight is the Intel Advanced Vector Extensions, or Intel AVX. This is a new microarchitecture enhancement on Sandy Bridge processors, wherein the 128-bit floating point and integer execution block are harnessed together. This increases the vector lengths for floating point operations like additions, multiplications, and others to 256 bits, leading to improved performance for workloads with a lot of floating point operations.
If you think about which applications are floating point intensive, this demo illustrates the use of AVX for face detection, which enables anonymous video analytics. AVX can also be used in scientific and engineering and numerical applications, visual processing, recognition, data mining, synthesis, as well as many others. A brand new architecture enables brand new use case scenarios, along with fantastic new technologies such as Intel AVX, Intel QuickSync HD Video, Intel HD Graphics. These combine to make the 2011 embedded desktop platform featuring the second generation Core microarchitecture, formerly codenamed Sandy Bridge, a game changer.